Yeah. One of the big differences between the hyperbola and the ellipse is that the hyperbola has subtraction between the two, whereas the ellipse was an adding between the two. The other thing that I want you guys to notice is when you're working with the hyperbola, just at the formula, is notice what happens with the A's and B's. The A's and B's stay the same. What moves? The X's and Y's. So it's no longer the A's and B's showing you what direction the graph is going to go. It's the X and the Y, what comes first. Okay? The X and the Y tells you which direction it's going to go. All right? I saw the fist bump. I saw the fist bump. Good for you. Okay? You should be happy. The X and Y show the direction. No, the A's and B doesn't. Okay? The A and B values still mean the exact same thing as it did before. The A value is still the distance from your center to vertex. Your B value is your center to what's called a co-vertex. In a hyperbola, it's not technically called a co-vertex. To be honest with you, I don't remember what it's called. I just call it co-vertex because it has the B value. And then the C value is still the distance from the center to focus. Within every other image that we've drawn and worked with, our vertex always opened up to the focus. Whether it was the parabola, when we had a parabola, here's your vertex, here's the focus. When we had the ellipse, your vertices were here and here, the focus were on the inside. When you get to the hyperbola, if the x squared comes first, that means it's opening left and right, and the vertex, it's still looking at it. If the y squared comes first, it's opening up and down, and it's still looking at it. Okay? Which means the C value is further away from the center than the vertex. So the formula for finding C is a little bit different. When we're dealing with these guys, it's out of the way. The C squared term is found by A squared plus B squared. Okay? So you still have the roots, just like we did before. Simplifying square roots, because you know the square root of 12 is 2 root 3, not 2 root 6. People. Yes, ma'am?
Those dots, are they foci or vertices?
Okay. I'm just showing that because where the vertex is, the vertex on the curve, it's still looking at it. Okay. Really, the main difference here when we start looking at the hyperbolas is that the hyperbola is drawn a little bit differently. It takes a little bit of time to get accustomed to what you're drawing, and here's why. It looks like this when you do it. Don't freak when you look at this here. All right? What I want you to see is that within these hyperbolas, I'm just going to look at one of them at a time. What's the password? Yes. Nope. Nope. No. What's the password?
Hannah is the bomb. Oh, she got it.
I just feel bad for you for saying that.
Hannah is a
Let me walk you through what's happening here. In these hyperbola graphs, one thing I want you guys to notice that occurs is that you get this rectangular box that's drawn. Through that rectangular box, we get what are called diagonal asymptotes. It is a fun word. You get what are called diagonal asymptotes. These asymptotes, you know what an asymptote is, right?
No.
It's a line that you're always approaching but you never exactly touch. It's like, I'm not touching you, 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 I'm not touching you. See, I can get infinitely closer and closer and closer without touching it.
Is that the thing where you like take it like halfway and
Yep.
halfway and halfway?
Yep, exactly. It means it's the same basic principle. It's you're always approaching a specific value, but you're not quite going to get there. So with these asymptotes, is that the curves of these conics of the hyperbola, they're hugging the asymptote, then they switch through and they hug the other side of the asymptote. It's very simple how to graph these. One thing you'll notice is that depending upon the size of this rectangular box, which direction it's being stretched, you can have a very skinny and tighter asymptote, so you have a smaller curve. You can have things like that. This is how you're able to tell whether or not the curves are very wide or very narrow. That's what those asymptotes do. In this class, we're going to actually find the slopes of these asymptotes. It's very, very simple, because what is slope?
I'm not supposed to change your rule. Is that right? Yeah.
Okay, change y, change x, change rise over run. Now, if I'm just looking at this real quick, oops, get rid of this real fast. If I'm looking at this, and I'm starting at the origin, I go up and over. Everybody agree with that?
Yes.
I went up to B, over to A.
Yes.
Eventually, I'll be able to figure out what these ordered pairs are, and I'll be able to write my slopes. You're going to use these not as much in Algebra 2, but you'll use them a lot more next year in pre-calc. I'm just trying to get you guys accustomed to what the terminology is, as well as how do you solve them, okay? Because I think we talked about this also, is that eventually you're going to take your hyperbola and you'll shift them diagonally as well, as opposed to vertically and horizontally. We'll shift them diagonally, but you'll do that next year. And these are called slant asymptotes. Diagonal asymptotes, slant asymptotes, along those lines, okay? So before I get into too much of the craziness here, I'm just going to go right into a problem of graphing and show you how it works. So let's start with x squared over 16 minus y squared over 36 equals 1. I'm going to label and graph all important parts. Yes, sir. So when we start out with this one, yes.
Okay, so is it the same thing where like a squared will always be the bigger one?
No. Since this is an ellipse, and I was just going to get at, remember what I said a couple minutes ago. The ellipse, the a squareds and the b squareds don't show you anything. The a squareds and the b squareds really have no rule in which direction it's going. It's the numerator this time. What comes first in this problem, x or y? So that means it's an x squared hyperbola, which means it's moving left. Oops. Means it's going to do that. All right. That's how you're able to tell what direction things are going. It's all dependent upon what comes first, x or y. If the y came first, it'd be going up and down. If the x goes first, it's left and right. And it'll be the exact same thing next week when we do h's and k's. The only thing that changes here will be x minus h squared, y minus k quantity squared. And then you do the same stuff. Today our h and k is just at 0. All right?
Got it.
All right. Now, I still do the same thing. I list out a squared. A squared is just always, now with the hyperbola, is always the first value. B squared is the second.
Yes.
16, you need a calculator for 16 and 36?
No, wait. It's 52.
52.
And they got 12 around 4 and 12.
Okay. Now, let's go through our roots. What's the square root of 16?
4.
4. So A will be at plus or minus 4. B, plus or minus 6. C,
Plus minus 2
2 root 13. Very good. Okay? Now, just like we did last time, we always start with, when we first did ellipses, we started working with them at the origin. I'll do the same thing here today. Our vertex is at the your center is at the origin. Our A value is always the distance from the center to the vertex. Since this is moving left and right, which direction is my vertex? Left and right. My B value then is my distance from my center to the co-vertex. So I just go up and down 6 now. And now I'm going to draw my rectangular box. I box these 4 points in. And then I put in my asymptotes. I put in my, I know it's a funny word, isn't it? It sounds like you're saying something wrong, but you're not. Put in your slant asymptotes, diagonal asymptotes if you want. Just like that. Yes, sir. Always. Okay? They're the diagonals of the rectangle. Okay? Now, before I plot anything else, I'm going to find the slopes. Okay? I'm looking at this. I went up to 6 over to 4. So it was 6 over 4, otherwise known as? Correct. So my slope of my asymptotes are going to be plus or minus 3 over 2. Those two slopes we're going to have, they're going to be the same except opposite signs. Not necessarily perpendicular. They're just going to have the same slope, just different signs. Okay. Does that make sense?
Got it.
Now, I know that in the book and in some of the generic formulas, they show you how to find the slopes depending upon which value it is, x squared or y squared. I've always found that it's just as easy to walk it. I always think because you won't screw something up. Yes, ma'am. I went up 6, I went over 4. Rise over run. All I did there. Okay. If I did the other one, I'd go down 6, right 4, so it'd be negative 6 over 4, so negative 3 over 2. That's why we write them out both for both. All right, so now I plotted out my center, my vertex, my co-vertex, if you will, and then lastly, I got to put in my foci. So the focus are located at plus or minus square root of 52. Square root of 52 is bigger than the square root of 49, but smaller than the square root of 64. So it's just to the left and right of 7. A smidge more or smidge less than negative 7. Here's 1, 2, 3, 4, 5, 6, 7-ish. Okay. And now comes the curves. Hug the asymptote, go through the vertex, hug the other asymptote. Yes, I said hug the asymptote. And that's your curve. All that's left to do is label your points then. Our center today is at 0, 0. Our vertex was located at negative 4, 0, 4, 0. The co-vertex, 0, 6, or 0, negative 6, 0, positive 6. And then the foci. Did I add the 2 root 3 to the x coordinate or the y coordinate? To the x. So it would be 2 root 3 comma 0, and then, oh, excuse me, root 13, and then negative 2 root 13. Correct. And then next week when we come back and we shift them, we're going to add them to whatever your, that weird root value to whatever your center is, whether it's an H or a K, depending on it's going up or down. To be honest with you guys, there's not, I don't want to get too tricky in these things, The biggest mistake that you're going to have with the hyperbola is that you're still stuck in ellipse land, and you're going to think that a squared is always the biggest term. Ellipse land, it sounds like a fun place to be. Yes, sir.
So like, what are they trying to play for?
An hourglass?
So what's your saying?
There's, it's really difficult to come up with a real-world app of a hyperbola. Crazy people.
Why are we doing that?
They are a precursor to some of the pre-calc calculus stuff you get.
And it's like
When it-
calculus.
What's that? It's the concept of learning to learn. It's the concept of how do you get from a complex system, something like this, into the next level. We don't use it a ton in Algebra 2. I'm not going to lie. We do a couple of sections of it, we call it the comics. Later on, you can model a lot more of it when you get into pre-calc stuff, when they start moving them around again. Yes, ma'am.
So we need to know these things to understand pre-calc and stuff with pre-calc we can apply to real life stuff.
A lot more. There's a lot more. There's a lot more of real-world application stuff of the weird concepts when you get into pre-calc, because there's so many different. I don't want to say word problems, but there's a lot more modeling that you can do, and then you'll see how it's. I mean, a lot of you guys are in chem right now,
Yeah.
and you can see how a lot of these weird math concepts are built into the chem stuff. It really is. What's up? Hey, that sounds like a all right, you guys do this one. From just wandering around, it looks like everybody did just fine. You know that's going to go left and right because x squared comes first.
Wait, when you put this in your calculator, how do you get y?
What's that?
Yeah, how do you get y?
You really can't put this in your calculator. I mean, you can. You said solve for y. It's just a pain. D squared is that. So c squared is 130. So a plus or minus 7. B plus or minus 9. C is just plus or minus the square root of 130. You cannot simplify that any further. All right? Start plotting your stuff out. You're centered at the origin. Good old 0, 0. I know I'm moving left to right because the x squared term came first, so that means my center to vertex goes left to right. So I go left and right 7. Wow.
That was a nice.
You like that?
That wasn't the same.
Wasn't the same pattern? I try to keep the beat. So I got the beat. Did you guys watch the eclipse this morning?
Yes.
It was a lunar eclipse because the sun wasn't up yet.
Did you get any pictures of it? It was like a red show. My mom was
I was watching it at 5 o'clock in the morning, 5:30, the red moon. It was really awesome.
But like the sun rises in my room, like so like it rises it right in the room.
My mom actually has 6
Your slope, up 9 over 7. Slope plus or minus 9 over 7 for the slant asymptotes. Your C value is a square root of 130, which means it's larger than the square root of 121, smaller than the square root of 12, 9, 10, 11, 12, here-ish. 9, 10, 11, 12, here-ish, or whatever. Now, hug the asymptote, go through the vertex, hug the asymptote.
Not hug the asymptote.
Hug the asymptote, go through the vertex, hug the asymptote.
Really bad at hugging the asymptote.
You'll get better at hugging your asymptote.
Would you take points on a test if it looked bad like that?
Of course, because you need to learn how to hug your asymptotes. You have to know your asymptote from a hole in the ground.
Okay, wait a minute. Okay.
I got nothing. I'm sorry. The only thing I have not done is what? Label. Vertex. I got that up there. Vertex was at -7, 0, 7, 0. Covertex 0, 9. 0, -9. Foci 130.
-130. So are we going to have a test over hyperbola?
Yes, great question. What I'm planning upon doing after we get back next week is on Tuesday, we'll go over the shifted versions of these, talk a little bit about writing equations. Wednesday will probably take Wednesday to write the equations. There's a lot you can do with these for writing equations. That'll get us to Thursday. Thursday works out nicely to be able to do a 2-3-question quick quiz on just the hyperbola, and then we'll be able to do the first section of polynomials. This is the rare occasion that I would probably do a quiz and then start something new. The first section of polynomials is nothing new to you. It's review of how you work with exponent rules. It's literally 15 minutes of a couple of rules and some problems for you guys to practice to be able to continue working with polynomials for the rest of that section, okay? So as of right now, it looks like 2-3 questions maximum, graph them. Probably do a graph given the equation, a graph given in standard form where you have to complete the square, and then probably write an equation. So it shouldn't be so bad, all right? Let's do one more that has the x's and y's flip-flopped. So let's do 4y squared minus 36x squared equals 144. I just wanted you guys to see that sometimes hyperbolas do actually go the other direction. Since y equals, the y squared came first, what direction is this going to go? Up and down. So what do you have to do to make this work first? Sure. So go ahead and do that one, and I'll check it in a minute.
What's the bottom because they're going to start 36.
Oh my gosh, I drew the wrong. I hope the wrong.
No, it's the same thing anyways. But
I just drew the wrong.
so it's A squared.
I drew the wrong answer.
I understand it, but
Is it?
Oh, shit,
I
you.
did it, Mr. Murphy.
Oh, he was so hard. Oh, it's
This is much easier.
5 by 2 is 10, 10.
Thank you.
Alright, Mr. Murphy. Look what you did.
I did nothing! You saw nothing!
See, how does it feel now?
Get because it is.
Don't worry, everyone was too busy talking to realize.
Nobody saw anything. It's all good. Alright? Then obviously in this case you still have to label it. This way. Then look at it! Look at it!
You drew it too.
Yeah, but
You did it too. Hey.
shut up!
I'm so confused. What happened?
Just nod and smile. Yes, sir.
I know the slope is right or wrong, but would it be 6 over 2 or 2 over 6?
Well, if you go up 6 over 2, so you rose 6 over 2, so it'd be 3.
Well, yeah.
All right, let me give you a couple of these to try out. This is on section 10.5, page 619. 31 through 36, just straight graphs, guys. Please be sure to label everything, just like you've been doing. I know that I kind of lapsed on that one. I didn't write out my ordered pairs. Please just write out your ordered pairs for all the stuff that you're going to do. Okay? The only thing you don't have, I mean, your centers are always going to be at the origin today, so shouldn't be all that scary. You're going to see real fast that when you shift these, it really isn't that bad. What happens is it's just, they're going to be floating out in space, so you might be doing a little bit of weirdness when you start at your original graph. Okay? We'll shift them up later. What's up?
No, we just said no.
Wait, I have it. Never mind.
Go ahead.
Okay, 619, 31 to 34.